Okay guys, today we're going to be taking a look at standard form of a linear equation. Right? We've been doing a lot of work with slope-intercept form where y is equal to mx plus b. Here, an equation is in standard form when you see the following. We have a coefficient of x plus times x plus some coefficient for y times y is equal to c. ax plus by is equal to c, where a and b are both not 0. Now, the other way, or simpler way of identifying standard form, x and y are on one side of the equation, and on the other side of the equation we have a constant. Now, how do we graph equations in standard form? Well, first of all, let's identify standard form here, right? We have x and y on the left side of the equation. We have a constant on the right side of the equation. The constant is all by itself. One way we can graph the equation is to write the equation in slope-intercept form, all right? So let's do that, right? Because we're familiar with that already. So if we take negative 2 times x plus 3 times y is equal to negative c. Right, let me just make this a bit bigger. All right, there we go. So if we do that, right, a little smaller, let's zoom out 125. Okay, so if we take that equation that's in standard form and rewrite it in slope-intercept form, that means we want to get the equation in the form of y is equal to mx plus b. So we have to solve this equation for y. Well, let's do that. We'd start by adding 2x to both sides of the equation, right? That's 0. Going to be left with 3 times y is equal to negative 6 plus 2 times x. Then we'd have to divide both sides of the equation by 3. On the left side, they cancel the 3's, so we're left with y is equal to, now, remember this 3 divides both of these terms in the numerator. And we want to write it in slope-intercept form where we have the x term first and then the constant following that term. All right, but let's divide first. Negative 6 times 3, that's going to be negative 2, plus 2x times 3, we're just going to write that as 2/3 x. If we rewrite that in slope-intercept form, we're going to have y is equal to 2/3 x minus 2. Right, so there's our equation in slope-intercept form. That's step 1. And once we have the equation in slope-intercept form, we graph it. We see that the y-intercept is negative 2. So I put a point at negative 2 on the y-axis. My slope is positive 2/3. So that means from negative 2, we're going to go up 2 over 3 to the right. And from there, we're going to go up 2 over 3 to the right. From there we go up 2 over 3 to the right. We get a collection of points in a straight path, and we want to be able to graph that line, right? And that's how we would graph an equation, or one way we can graph an equation in standard form. Simply rewrite it in slope-intercept form. But there's another way, right? And that's really the lesson today. The other way to write an equation in standard form, to graph an equation in standard form, is to use the x-intercepts and y-intercepts, right? And that's a slide that's going to come up a little later, but we're going to practice that now. And what do? Well, to find the x-intercept, we make y 0. So we're going to write negative 2x plus 3 times 0 is equal to negative 6. This is going to give us the x-intercept when we replace y with 0, right? And let's think about that for a second. Because if we look at the x-axis, what is the value of y anywhere along the x-axis? Well, the value of y anywhere along the x-axis is going to be 0, right? Because at any point on the x-axis, the y value is 0. So we find that x-intercept by replacing y with 0 and solving for x, all right? So when we do that, we wind up with negative 2 times x is equal to negative 6, right? Because 3 times 0 is 0. Divide both sides by negative 2. They cancel. and we get an x-intercept of, right? Divide both sides by -2. We're going to be more careful. That's going to give us an x-intercept of 3. Right? And then to find the y-intercept, we replace x with 0. Right? So I got to do that. So I want to write -2 times 0 plus 3 times y. That's equal to -6. Right? Should move that over a bit. Right, do that like that. And let me just fix that -6 here. Right, just give myself a little more room. Okay. And then to solve that equation for y, right, because that's now 0, we get 3y is equal to -6. Divide by 3, divide by 3, they cancel. Right, we get y is equal to -2. Right, so now we have an x-intercept and we have a y-intercept. And we can graph an equation that way using the x-intercepts and y-intercepts. Right, we said our x-intercept is +3. Well, that's this point here, right? Our x-intercept here is +3. We said our y-intercept is, -2. Got to be a little bit more careful because -6 divided by 3 is -2. Right, a y-intercept of -2, right, and that's down here. So we could use those 2 points, right, our x-intercept and y-intercept to graph the line. Right, so we're going to have 2 different methods, that we can use to graph the equations. We can graph equations using the slope and the y-intercept, but that means we have to rewrite the equation in slope-intercept form, or we can use the x-intercepts and y-intercepts. Right, so let's continue. Now, this next page says, on your own, we want to graph the equation using a graphing calculator to check. Well, we're not going to use the graphing calculator, but here's what we have to understand. We want to be efficient math students. So if an equation is written in standard form, it's probably easier for us to use the x-intercepts and y-intercepts, right? If the equation is in slope-intercept form, then we use the slope and the y-intercept to graph it, right? So let's look at these equations here. Now usually, right, let's, like this one we could do mentally, right? Because if we replace x with 0, y is -2. If we replace y with 0, we get x is equal to -2, right? So look how easy that graph is going to be. We know we are going to have a point where y is -2. We're going to have a point at x is -2, right? And we can draw our line right through those 2 points, right? And I could extend that line and move it just a little bit, right? And arrow here, and there's my graph for x plus y is equal to -2. Now if we wanted to, we could rewrite that into slope-intercept form, right? So let's take that, right? Because we have x plus y is equal to -2, right? And if we solve that equation for y, right? If we solve that equation for y, right, we'd subtract x, and we wind up with y is equal to -x minus 2. Right? And if y is equal to -x minus 2, we could check that graph. Our y-intercept is -2, right? That's down here. My slope is -1/1, so that would be down 1/1, right? Down 1/1, down 1/1, right? So we can see if the equation's in slope-intercept form, right, we graph the equation correctly using our x-intercepts and our y-intercepts. All right. Let's continue with example 2. Now, problem 2, once again, I'll use different color. Right? Problem 2, that equation right now is in standard form. How do I know? Because I have x and y on one side of the equation and I have the constant on the other side of the equation. So, if we find the x-intercepts and y-intercepts, let's see if we can do this quickly. Right? If we make x 0, right, so I'm going to replace x with 0. When we replace x with 0, we get 2 times y is equal to 6. So that gives us a y-intercept of 3. And if we replace y with 0, right, so let's erase that. I'm going to replace y with 0. Right, that's going to give us what? Negative 1/2 is equal to 6. Going to write that one out. That's a little tougher to do mentally, right? Negative 1/2 x is equal to 6. And then we'd have to multiply what? To get x by itself, multiply by negative 2, multiply by negative 2, right? They cancel, right? Negative times negative is positive, so that's going to give us 1x is equal to, what's that going to be? Right, that's going to be 6 times negative 2. That's going to be x is equal to negative 12. Well, that's kind of a tough one to do. Let's see, am I going to be able to fit that? X is negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to have an x-intercept all the way over here. My y-intercept is positive 3. Right, so my y-intercept is up here. So we're going to have a line that looks something like that. Let's graph it, if I did that correctly. All right, because we did, let's see, 1/2, right? Make y 0, we get negative 1/2 x is equal to 6. Right, yeah, no, that's right. And let's draw a line, arrow here, arrow, arrow, right, and that would be our graph. But let's rewrite that in slope-intercept form, right? Let's double check it. So I'm going to get, let's see, I'll do that down here. We have negative 1/2 x plus 2 times y is equal to 6. If I'm rewriting that in slope-intercept form, right, get y by itself, first I'd have to add 1/2 x, right, to both sides of the equation. Add 1/2 x. That's going to give us what? That's 0. That's going to give us 2 times y is equal to 1/2 x plus 6. Right, and then we would what? Divide by 2, right? Divide by 2. Divide by 2, right? They cancel. Wind up with what? Y is equal to 1/2 divided by 2, that's 2 over 1, that's 1/4 x plus 3, right? And I think that's right, right? Because then if we're graphing in slope-intercept form, our y-intercept is 3, so here's our y-intercept, and our slope would be up 1 over 4, right? And that's exactly, right, if I extend this line here, that's exactly the line we have, up 1 over 4. So, yep, our x-intercept and y-intercept was correct. Right? But once again, the point is that we can use either method. We can use our x-intercepts and y-intercepts to graph the lines, or we can rewrite it in slope-intercept form. But when the equation is in standard form, we want to use the x-intercepts and y-intercepts. Because it's a more efficient way to find solutions, right? It's a more efficient way to graph each equation. Okay, let's continue. Let's look at problem 3. Problem 3, we have negative 2/3 x plus y is equal to 0. Let me recopy that. Problem 3, negative 2/3 x plus y is equal to 0. Okay, well let's do the x-intercepts and y-intercepts here. If we make x 0, y is equal to 0. That's easy. Well, let me do it over here. Right, so if we make x 0, y is going to be 0. So we get a y-intercept of 0. And then if we make y 0, what do we get? We get 2/3 x is equal to 0. To solve for x, we'd have to divide both sides by negative 2/3. We get x is equal to 0 as well. Well, there's our x-intercept. There's our y-intercept. Right? So we get what? We get an x-intercept of 0. We get a y-intercept of 0. Well, that doesn't really help me, right? Because it's not a line, right? But we do get an x-intercept of 0. We get a y-intercept of 0. So if we're using the standard form of the equation here, right, it doesn't really help us with our graph. That's why we need another method. So let's solve for y. If we solve for y, we're going to have to add 2/3 x, right, to both sides of the equation. Add 2/3 x, right, and we wind up with what? Y equals 2/3 x. Now we can graph the equation because we do see that this point is real, right? We are at the origin where x is equal to 0 and y is equal to 0 because we see that the y-intercept is 0. But now we have a slope of 2/3. So we'd go up 2 over 3, put a point, up 2 over 3, put a point, up 2 over 3, put a point, right? We get a collection of points in a straight path, right? And we kind of see the importance of needing two methods there, right? Because if we're trying to use the standard form's not going to help us with the graph, right? Because we got an x-intercept of 0 and a y-intercept of 0. Standard form doesn't help us. We want to be able to graph that equation. We had to rewrite it in slope-intercept form. Okay, and then our next one. What's question 4? 2x plus y is equal to 5. We'll do that in purple. Right, 2x plus y, question 4, 2 times x plus y equals 5, right? So let's talk about x-intercepts and y-intercepts. If we make x 0, y is equal to 5. If we make y 0, x equals, what's that, 5 over 2. Right, 5 over 2 is the same as 2.5. Right, so if we're using our x-intercepts and y-intercepts, we'd have a point, we'd have a point up here at y is equal to 5, right? Here's your y is equal to 5. Your x value is 5 over 2. 5 over 2 is the same as 2.5, right? There's 2.5 on the x-axis, or 5 over 2. Draw a line through those 2 points, right? And there's our graph, right? There's the graph of that equation. However, right, let's rewrite it in slope-intercept form, right, just to see that equation in slope-intercept form. So I'm going to rewrite it down here. 2x plus y is equal to 5, right? And this way we could see what the slope and the y-intercept should be. Right? We'd have to subtract 2x to get y by itself. Subtract 2x. We wind up with y is equal to, what's that, negative 2x plus 5. And I think that's exactly the line we see, right? Because our y-intercept is up here at plot positive 5. Our slope is negative 2, and as a fraction, that's negative 2 over 1. So that's down 2 over 1, down 2 over 1, down 2 over 1, right? So that line as well is correct, right? So we're able to use the slope and the y-intercept, or we're able to use the x-intercept and the y-intercept to graph equations. And the goal is just to be, more efficient math students. So the more choices or options we have to graph these equations, the better off we're going to be. All right. So here we're told to use x-intercepts and y-intercepts, right? Just like we were talking about earlier. So we want to replace x with 0, right? If we replace x with 0, we get 3 times y is equal to negative 3. So we divide by negative 3. It doesn't matter. Right? Divide by 3, and we get a y-intercept of negative 1. Right? If I want to find the y-intercept, if I want to find the x-intercept, we want to replace y with 0. Right? So if we replace y with 0, we get x is equal to negative 3. So we have y is negative 1. That's down here. We have x is equal to negative 3. That's over here. Right? There's the graph of our line. Right? Looks something like this. Alright, looks something like that. If we had that same equation, let's write it. X plus 3 times y equals negative 3. And we write that in slope-intercept form. Right? That's going to look like what? Subtract x. It's going to give us 3y equals negative x minus 3. Then we'd, divide by 3 on both sides of that equation. They cancel. Right? Y equals, this is negative 1 over 3. So that's negative 1/3 x. Negative 3 divided by 3 That's negative 1, right? And isn't that the line that we have here? I believe so, right? Y-intercept is negative 1, and then we're going down 1 over 3, right? Down 1 over 3, right? Could have been a little neater with my line, so let me fix that. All right, could have been a little neater. Right, but yes, that is the graph of the line using the x-intercepts and the y-intercepts, right? Because here's our x-intercept, here's our y-intercept, or using the slope and the y-intercept, right? Slope and y-intercept. Okay, all right, that's pretty much the lesson that I wanted to record for you, because that's plenty of examples. You guys could practice these two on your own using your x-intercepts and y-intercepts to graph it. You can look at your guided notes to see if the attached guided notes, if you did them correctly. But remember, you have two options now to graph the linear equations. You can use the slope and you can use the y-intercept if the equation's in slope-intercept form. If the equation is not in slope-intercept form, you can rewrite the equation in slope-intercept form. Or if the equation is in standard form, where x and y are on one side of the equation and your constant is on the other side of the equation, you can use the x-intercepts and the y-intercepts to graph the equation by replacing x with 0 and solving for y, right, to give you the y-intercept, and replacing y with 0 and solving for x to get the x-intercept. All right, I hope that's been helpful, and we'll see you soon.